1.2. I am going to skip this only because this takes a deeper and more extensive amount of time to interpret what's going on. Real quickly, they do want us to look and describe what's happening in these functions. Obviously, at the time that you're 0 age, it takes you a little bit longer to think. Rather than you being in your 30s, you're able to think faster. And when you get older, it also creates the curve like, oh, okay, we get to a nice age, kind of over the hill. A lot of us are gonna eventually remember that from Mr. Ramirez. You're gonna go over the hill, and when you go over the hill, you got a lot of coming towards you, I promise. But gonna skip 1.2 and jump right to 1.3 just to save some time. This is a lengthy lesson. Skipping to 1.3 for sure. Okay. Bringing it out. Here we go. All right. Adding and subtracting. I'm so excited about what's about to happen, because if we read this story real fast, you are playing a new virtual reality game called Species. You are an environmental scientist who is responsible for tracking 2 species of endangered parrots, the orange-bellied parrot and the yellow-headed parrot. Suppose that the orange-bellied parrot's population can be modeled by the function b, right here, where x represents the number of years since the current year. Suppose the population of the yellow-haired parrot can be modeled by function h. So this is our orange, and this is our yellow. Okay. And we could look at it on the graph. Okay, I'll make a little marking right here. So this is our yellow, and this is our orange. And as you can see, our orange is coming down drastically, where our yellow started and started coming back up. Okay, so your task in this game, I guess it's a game, is to determine the total number of endangered parrots. Okay, so we're gonna see what happens if we combine the two. What is our years? Okay, you can calculate the total population of parrots using the 2 graphs function. Let's use both graphs to create the function t of x, and this represents the total amount. Now don't forget, the total amount means what? We are adding. Okay, so let's write this in terms of t of x. So t of x equals the total amount, which is b of x plus h of x. I'm adding my orange, I'm adding my yellow parrots, and we're gonna get our total amount of parrots. Okay, we need to break it down. We can break it down. This is our orange plus our yellow, and this is our total amount. Okay, pretty cool stuff. I enjoy a lot of this polynomial stuff. Remember, if you need to take a pause, please take the pause. Here we go, rocking and rolling. Predicting the shape. Okay, predicting the shape of t of x. That means we're just wanting you to be able to look at it and figure out, okay, what's gonna happen. Okay. Wish we had more space here. Okay, let's see what we're gonna do. Sketch the graph of t of x on the corner plane. First, choose any 5x values and add their corresponding y values to create the new point of the graph t of x. Then connect the points and smooth the curve. Record the values on the table. Of course, we can start with whatever point we want to. I reckon that we start with 0. Start with 0, we start with 1, we start with 2, we start with 3, and we start with 4. Probably go up to number 2 just so you can get an idea of what exactly we're trying to accomplish here. Like I said, I wish we had some more paper, so I'm gonna write this real fast. B of x is on the previous paper, negative 18x. No, I did that, sorry. plus 120. And then our h of x is equal to 4x squared minus 5x plus 25. Making a table. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Gonna show you how to make a table real quick on your calculator. Take it out. Clicking y equals here on the top. First tab, I'm gonna type this in. Don't use a parentheses. I didn't mean to put parentheses. Negative 18x. If you don't know where x is, there's an x button right here. Plus 120. After I get that going, table is right there in blue, so I'm gonna click second graph, which is table. There's my table. So I get to put my y values in very quickly. 120, 102, 84. Oh, my bad. 3 is 66, and 4 is 48. Same thing for h of x. Gonna come back to y equals. Gonna clear that so I don't get a little musty. 4x. I'm gonna press this little power button to go up. 2 minus 5x plus 25. Second table. There's my table starting out 0. We got 25, 24, 31, 46, and 69. Okay, I'm gonna copy that, put it right here on my table right there. So for b of x, we got 120, 102, 84, 66, 48, 25, 24, 31, 46, and 69. Okay, here we go. Adding these together, hopefully you can add 120 plus 25, 145. 102 plus 24, that looks like 126. Check my work, I think it's 115. I think this is 112. I'm actually gonna get a calculator for the x. Yes, I'm a math teacher, but you know, math teachers get tired sometimes, ladies and gentlemen. Okay, and that's our working values. Pretty straightforward. Of course, you could have chose any x values, but for right now, just to keep its order, we're gonna stay nice and stuck to exactly what we're doing together. Okay. Okay, I'm gonna skip number 4 because that's your opinion. Gonna go down to the worked example. This is the best part. So while we did each function on the top one by one and then we added them together, we could create a new function from like the warm up to create our t of x, so we could just have one table. Okay, if I put that in just to double check, I go to y equals 4x to the power 2 minus 23x plus 145. My table should match what I did up here on the top. Second graph. If we look at that 0, 145, 126, 115, 112, 117, that's exactly what we got here on the top for t of x. Very cool because we did it correct. Choose any two values in your table. Use the new polynomial. We just did that. Thank you, Mr. Ramirez. You're gonna make sure we always use y equals second graph to look at tables. Then use technology. We already did that. Check mark, check mark. We're kicking some butt. Let's keep going. Zoe says that t of x will not work after any time after 6 years from now, because by that point the orange belly parrots will be extinct. Is Zoe's statement correct? Why or why not? Sorry. So, she is correct. Okay? She is correct because basically our first function b of x will zero out. Meaning we can't go negative, okay? It's not possible to have negative parrots. So she is correct. And as you can see, if we look at this graph real fast, this is where our parrots go bye-bye. So that's something to consider. All right. Number 5, use b of x and h of x to determine the function d of x, which is the difference. Circle that. Difference is subtracting. Write d of x in terms of b of x and h of x. Make sure real quick. Beautiful. We're going to say d of x, our difference, is the b of x minus our h of x. Predict the shape of the graph. This will be an upside down or reflected graph. Okay, it's going to look something like this. You can definitely do that on your own. Did the graph of d of x match your prediction? Of course, you can definitely make the tables on your own. Definitely give yourself some practice. We already did this together, and you can figure this out. Definitely do this on your own. You have this number, you have this number. Now you're just figuring it out. Subtract it. Try with 0, 1, 2, 3, and 4. Beautiful. I love it. Do this on your own. A lot of good practice for sure. Okay. Next video 1.4. Oh wait. I didn't see backside 12 almost left. Oh, okay. We can do number 10 real fast together. Number 10 is just telling us now we got some new functions. So make sure you know total, difference, help you out real fast. S of x equals w of x plus L of x, M of x, the difference, subtracting, w of x minus L of x. Now, if we did this, you would get something real nice and neat, okay? Let's do it real fast. X equals wx negative 9x plus 80 plus 2x squared minus 4x plus 10. All right. This is the good stuff right here. Does negative 9x, can we add that to somebody? Most definitely. Negative 9, so it's smudging, that's okay. Let's just highlight all the good stuff. 80 can be added to 10, looks good. And then 2x does not have a partner. So since 2x does not have a partner, I'm going to say that our S of x starts off with 2x squared. Going to add these two real fast. Negative 9 plus negative 4. Negative 9 plus negative 4. Negative 13x. Don't forget the x. And then 90. Oh, I already said it. 80 plus 10 is 90. Terrific. Do the second one real quick. M of x equals w negative 9x plus 80 minus, be careful, 2x squared minus 4x plus 10. Same scenario. We already know the partners. Now, be careful. This negative sign does come over and takes care of all this stuff. So it does change a little bit of good stuff. Now we have to recognize, since it's minus, this changes it to a negative 2x. Negative 2x squared. And then we could just read the other ones just as this. Negative 9x, oh, not x, sorry. Minus negative 4, gives me 5. Negative 5x. And then 80 minus 10 is 70. Okay. Right here, if you calculate on your own, for part C, 4 and 4, you substitute, you look for it in the table, and you find your answer. Meaning, go to y equals, look at your table, what is 4 for s of x? Go to y equals m of x. What is your x at 4? What is that answer? What is that answer? And interpret what's going on. Okay? A lot of good stuff in this lesson. It was extensive. 1.4 is going to be another good amount, and 1.5 is still another good amount. Okay? Man, this is extremely long, so definitely if you need to split this up over 2 days, most definitely do it. Next video.